Dynamics in Messiah is readily available inside Setup under an effect called Motion Dynamics. There's also one called Soft Body Dynamics, or there's Gravity. All three effects do very good things, but they also include a number of factors that you might not need for your animation, such as wind resistance, gravity, friction, bounce. What if you just want a really simple drag behind? This is what I'd like to call fake dynamics. Dynamics that just use the keyframe information to create the rest of the chain. So you're not really running a simulation, you're just running a basic algebra problem. So with a little creative programming, we can make a dynamic chain very predictable and very repeatable. So the first thing we'll do when we set this up, let's go to Setup, and under the Tools tab, select Skeleton in the Tools pull down. Click on the plus button to add that to the scene. We'll go back to the Items tab. Close down the new item block so we have some room. Switch to a left view. And while the skeleton is highlighted, plus key on the keypad to add bones. So we'll add 3 bones in a hierarchy. Start with bone 1. Click into the Animate tab, and we'll just do a quick animation. Go to frame 10. We'll move it all the way up. Go to frame 20. Down. 30 up. 40 we'll just step down. And then 50 back down to 0. So when we play through this animation, we just have a simple translation on the very first bone. Let's do some programming magic. Let's click into the Command tab. We'll create a new variable from the Variables tab and switch to Expression. Right-click on the buffer to add that to the Expressions field. You'll see it shows up here in your variable as well. If you click on the debug, we'll have a value that's being represented right now as this animates. So as we scrub up and down, we can see that a value is going in. See that the value is going in at the top, 1.7, and then it goes back down to 0. We need to define a negative direction if we're going to play with dynamics. So how do we do that? Well, the answer is pretty simple. We need to find a change in direction. We need to find out if it's going negative. We do that by taking samples, which means we subtract wherever it was before from wherever it is now to get a change in direction. Let's expand the field here. And we'll copy this and we'll subtract itself. Well, that seems nice, except it's subtracting all of itself but not itself from the previous time. There's a little known feature called now. If you go to the last part of the field and type the @ symbol, now in capitals, you're telling Messiah to check the current frame. Well, it's already doing that. But if you go now -1, it will check the frame before it. Now what we have is a change in direction. So instead of seeing this at 1 meter, we're seeing it as a change in direction of 0.01 meters. Since it's changing really fast in the transition between the keyframes, you see the change is 0.2. To better describe this, click on the pitch channel and go to the Channels tab. Check mark to make it active. We'll add that channel to this variable. So as the change in direction occurs through our little piece of math, the pitch channel is affected, and it looks like we're dragging through air. Let's propagate this down the list. So let's grab our variable. We'll copy that. Since our skeleton is all labeled 1, 2, and 3 at the very end, we'll just edit the expression directly to represent 2, bone 2. Now the now -1 says check my previous frame, but we can lag it even further by checking the second frame ago. Highlight the pitch channel, go to the Channels tab, and we'll highlight bone 2 as the pitch. So now as we go and we take a look at it, well, didn't look like it changed anything. Why not? Well, let's debug. You'll see that this second variable has no values on it. Well, that's because this, being a parent of this, doesn't have to translate. Its parent translates for it. But there's another feature inside Messiah called world position. Let's edit this directly again and go just before the YPOS, type in W. So it's the world Y position. Do the same thing here. Now what that does is it checks the position of this bone straight from 0, no matter where it is in the hierarchy. And this bone now shows up as a change. And these two numbers are completely different because this pitch is affecting how tall this one is in world position. So now as we move it, it lags behind. So let's pick this variable. We'll copy that to the last one. So let's go change this to bone 3, so it will control bone 3, and we'll have it look backwards 3 frames. Select the bone 2 pitch channel, switch to channels, and select bone 3 in the pull down menu. So now as we play this, you can see that the dynamics are being calculated through simple subtraction math. Now this works the same on heading as well, if you just do an X position instead of a Y position. So you can get multi-axis fake dynamics. Let's go to File, and just to make sure we're in the right project directory, go to the Minitudes 2 folder, Dynamics folder, click OK. And we'll save this scene as, into the Scenes folder, FakeDynamics.fxs. If you look in the Rig Models folder, the sauropod has his tail rigged exactly this way. Click Save.